Why have software-defined networks on a quantum communication infrastructure? In a project like PTQCI, the Portuguese quantum communication infrastructure, creating a network for quantum communications needs to start small and as simple as possible. This way, we can deploy the necessary infrastructure to make services like quantum key delivery available in a limited set of locations with a reduced capability set, just enough to be able to demonstrate the feasibility and start exploring a limited version of the service. In Portugal, this first step is being taken by making quantum interconnections between a central node and other nodes in 3 different locations in the metropolitan area of Lisbon. This 3-pointed star network is already covering a wide set of challenges for quantum key delivery. For one, each of these interconnections is using technology from a different vendor, which allows their evaluation for future purchases and avoids vendor lock-in from the beginning. Then, for quantum key distribution between the central node and the tips of the star, we have the simplest scenario, but we can already add some complexity for key distribution between 2 tips of the star, where the central node also has a role to play. Also, this star topology is very appropriate for a metro distribution network. Adding tips to the star doesn't add much to network complexity. But this network will grow in the future. Terrestrial long-distance connections will involve sequences of relay nodes, and alternate connections will be available for path protection, creating loops and enrich a set of connection alternatives. While at first a simple scenario can be statically configured, meeting this complexity with static configuration of network nodes will be more and more difficult as the network grows, and at some point in time the paradigm change is needed. So, for the Portuguese quantum communication infrastructure, it was decided that the quantum communications network will be a software-defined network from its very beginning. In short, this means that instead of static configurations in each node, we will have a controller which is aware of the overall topology and state of the network, and upon request from applications demanding key material, will be able to set up an optimized quantum path for key delivery across the whole distribution network. When the network changes because a node was added or removed, or a link was broken or established, then change is acknowledged by the controller, which can automatically take actions to adapt. The alternative with a statically configured network could involve a costly engineering project and much longer times. Further into the future, this national infrastructure will be interconnected with other similar networks across Europe. Also, new services relying on quantum communications will come to life. We believe that having the flexibility of a software-defined network to tackle these challenges will prove vital for the success of our quantum communications infrastructure.